It is wonderful to be in front of this audience of UX and especially UX research people. So I feel like I'm at home. I started out as a UX researcher and as a psychologist, and that's something we're going to talk about today, about a special opportunity that people in this UXR community have in the AI space. And in particular, I'm just going to tell you now, I believe that everything that's happening in the AI space is identical to everything that has happened in the development of the social sciences 50 years earlier. So we are seeing all of these developments happen in real time in an accelerated manner. And I sometimes joke that talking to the computer scientists who specialize in AI is like going to an alternate universe where social science has been discovered by people who have programming backgrounds, and they have not experienced any of the trials and tribulations that we've all developed. So I know many of us are social scientists in terms of background. If you're not, you're probably still using methods that were derived from those different disciplines. And let's talk about how they show up in AI. So that's what we're going to talk about. We'll talk about definition of terms. We'll talk about what we mean when we talk about AI. And then we'll also talk about that history. And I'll show you a few case studies from my teams at Google Research. Okay. So in Google Research, I lead the AI. For example, we have a studio team that looks at whatever the latest technology is that's coming out of Google Research and how it might apply to our products. We have a team that's working on healthcare. We have a team that's working on climate change. We have a team that's working on responsibility and AI ethics. And between us all, we get access to some of the world's best AI researchers and new capabilities, almost none of which I'm going to show you today, but I'll talk about that in a minute. Some of the technologies that we have worked on in the past include Google Translate and the ability to use machine learning to do automatic translation in real time, including, as you see here, the ability to match the type of content that is shown up in the video. We also worked on a project called AIY. This was briefly available. I think it's a collector's item now, briefly available at all Target stores in North America. It is a cardboard-like device that allows you to build your own version of the Google Assistant and was designed for kids in STEM situations. It's still currently available as a developer platform and a reference for TPUs. We also worked on a project called Pixel Top Shot. Some of you who have Pixel phones may have used it. It basically uses artificial intelligence to guess which photos in a burst that is taken automatically are the best photos in terms of composition, in terms of position of the face, smiles, things like that, and allows you to pick the ones that the AI system recommends. So in many cases, we wind up taking better photos through the AI system than what the human thought they took, but we want to transparently allow the human to make that decision for themselves. We also have a team working on medical products. So for example, we're working on AI-assisted mammography, the use of AI systems to very, very rapidly screen radiography images and things like that, detect different kinds of anomalies. And this project is fantastic because of the UXR component, right? Google researchers are great at doing things like image recognition. They are not great at understanding, the medical space without the help of UXR, which goes into the field, talks to clinicians, talks to patients, figures out what the workflow looks like. Similarly, we just did a project with American Airlines on contrails. So contrails are those clouds that happen out like behind aircraft under certain weather conditions, where the exhaust mixes with certain weather conditions, causes these clouds. Turns out the clouds account for a very large percentage of the global warming impact of aviation. And so we did a partnership with American Airlines where, the leads from American basically said, if you think you have a way of reducing these contrails and affecting our global warming footprint, we would like to know about that. And our UX team went out into the field, partnered with American, figured out the workflows that pilots have to go through, figured out how to integrate our technology, which predicts the flight level that we need to be at. And just published a 6-month trial. We found that in aviation, we can probably reduce the...
I didn't get that. Could you try?
About 1% of all. And that's the power of UX research, right? Being able to go into the field, figure out the feasibility, figure out the design needs, and then make these kinds of things possible. Another example of AI work that we're doing in research is Google MakerSuite. MakerSuite began as a prototyping platform because we realized that with a lot of AI technologies, it takes a really long time to figure out how the AI models work, get them running, and then put them in a prototype that somebody could actually test. For us, on our team, it was taking maybe a couple months for some of these prototypes to happen. So we started building our own tools to try to speed that up by using APIs and allowing really simple, and in some cases, limited coding environments. And we turned that into MakerSuite, which we debuted at I/O. It's a way for the developer teams or any UX prototypers that you work with to get access to a lot of Google technologies early and see if they work for the application you've got. Okay, so I warned you guys about this. You'll notice that I didn't talk about any recent generative AI stuff. You didn't see a single chatbot in this presentation. There's two reasons for that. Reason number one, not allowed to show you some of the cool stuff that we're working on right now, although it is very cool. Reason number two is I want to make the point that what people are calling AI lately is not necessarily all of the spectrum of AI. And the things that we're going to talk about, language model that you're interacting with through chat, like the OpenAI models or Google's own Bard system. It also applies to multimodal, to anthropomorphized things, but it applies to translation. It applies to prototyping. It applies to image recognition, right? And the parallels that are drawn between how we understand human beings and how we understand all of these capabilities are huge. Okay, so let's start by talking about this process. The process begins at the top. We've got observe and question. We've got hypothesize and take a stand, intervene to create new features, learn fast through prototyping and testing, going through a feedback loop, and then Eureka, it works. Let's think about the next version. What do we call this process? Just hands up. Scientific method, yes. What else do we call this process? Design thinking, yes, that's right. And I'm gonna let you guys off the hook and say that yes, it's all of those things, right? This process is science. This process is user research. The process is also design, and the process is artificial intelligence. Any one of those different topics can be described through this process. It just depends on where you're putting the emphasis. For many of us as UXRs, we're putting a lot of emphasis on observing and questioning, hypothesizing, and testing. For our designer friends, they put a lot of emphasis on intervening. And for AI systems, they spend a lot of time thinking about training models and then seeing how the models perform. So they're operating on the extremes. And there's a lot of history, and I'm just going to give you guys a short version of some of this history. We're going to start a long time ago, before fields like social science existed. So this is before psychology was a thing. In the 17th century, we had people like Descartes figuring out, like, how does the mind work, right? And the version of this that Descartes came up with is that the human body is full of tubes, and inside the tubes there is like a magical fluid, and that magical fluid makes things alive, and that is what psychology is. Now, where did he get this idea? Well, it happens that Descartes liked to spend a lot of time in gardens, and the fad at the time was for gardens to have robots that were animated by tubes inside of them that had fluids that push the arms up and down, right? So from the very beginning, we've got social sciences being born alongside engineering and using each other as models. In the late 1800s, zooming ahead, the field of psychology, which is where I come from, became mathematical. So we had people introspecting and figuring out, if they could time these mental activities that are happening. We have things that start to look like usability labs. This is Wundt at the beginning of psychology. Then we had a period in psychology where we lost our minds. We decided that introspection did not work at all. And instead, we needed to think of the human being as a black box where we study what goes in and we study what comes out. And then we hypothesize that there's a relationship between what went in and what went out, but we don't care or know about what happened inside. This is also my favorite image from the history of psychology. It is a picture of the founder of behaviorism dangling a baby. And it's a great study. I'm not going to tell you what it was about right now, though. But it led to a lot of innovations, right? By not thinking about the brain that's inside of each of these pigeons, they were able to get pigeons to do things like play ping pong. And there were a whole bunch of different technologies that were developed based on this black box understanding. And I'm going to make the case, just to spoil it, that this pigeon is a lot like an AI system, right? We don't need to understand how it works to understand the inputs and the outputs and figure out how to make it do cool stuff. And let's see if I can go next. In parallel, during this time, computers in the 1940s were also being developed based on neural plausibility. This is the first version of an AI system. It was modeled on the first research on the human brain and operates like a neuron. During this, back in psychology, we got our mind back through what was called the cognitive revolution. It was the first time we began to do things like this, generate models of what might be happening inside the human brain. They were crude, but they were a lot more predictive than the original ones. And now in the AI world, we're beginning to see a lot of work on introspection of models, interpretability of models, and understanding like what are the training data contributions that lead to model output. In psychology, we got really fancy with our methods. We developed experimental notation, validity assessments, a bunch of things that if you are studying like your first psych methods class, you're going to cover a lot of this stuff. Let's take a look at one quick example of how this old idea could operate in the AI space. One more game. This is Dr. Paul Fitts. We're going to play two truths and a lie. Please do not look on Wikipedia. Here are the things about Paul Fitts. Number one, he was in the Air Force. Number two, he investigated UFOs. And number three, he's the Fitts law guy. So for those of you who know Fitts law, it predicts the motion, ballistic motion toward a target. So any guesses on which one of these is the lie? Come on, guys, throw it out. Number three. Yeah, Fitts law guy. That's a good one. Nobody here is questioning that whether he worked on UFOs, maybe because of that picture that's up there. So the lie is that there's a lie here. He did all these things. Very interesting researcher from back in the day. Also worked in the human factor space. Fitts law has been something that in HCI is taught a lot. But from my perspective, one of the most important contributions for the next century is the Fitts list. It is the simplest possible list that you could create. It used to be called the men are better at, machines are better at. Now we call it the humans are better at, machines are better at list. And it's literally a list of things that machines are good at and humans are good at, right? And you separate them out. So you say something like, machines are good at responding quickly to control signals, and humans are better at detecting small amounts of visual, auditory, or chemical energy. And what Fitts would argue is that by understanding and documenting the role that you are putting a human in versus an AI system in, you can better understand how to fit them together in a system, right? You can figure out interaction design. And as we're working with AI systems that are more unpredictable, that have capabilities that are changing constantly, doing this kind of documentation at the beginning of a design process will help you keep track of the decisions that you make throughout the project, and also let you know when it's time to reconsider the entire product. And here's what happened after that. He started out this thing called the functional allocation movement, where he talked about how like we can predict how well human machine systems will operate, and a couple of pieces of philosophy that humans should not do things that machines are better at. So, we have a lot of debate right now in the AI space about automation. What Fitts said, almost 100 years ago is that instead of worrying about that, let's talk about what is right for humans and remove the tasks that are not meant for us as people to get better. And that humans should focus on things involving human judgment, which is a lot of AI in the loop kind of system aspect. Okay, in Pixel Top Shot, which is one of our projects, we can talk about the AI being able to process and pattern match in milliseconds, right? So it can tell us if the person was smiling and suggest that that might be a better photo. But ultimately, it's the human who decides the value of the photo and whether it's something that matches their goals, right? Now, if we think of both of these systems talking to each other as probabilistic, the same methods that we've developed to understand humans are the exact same methods that we can use to understand how AI systems work. So for all of you here thinking about UX research, I also want you to think about whether you are analyzing the AI system using these same techniques when you think about the training data that goes into the black box. Are you involved in model creation when you're working on these projects? Are you involved in assessment of both the human's performance, but also the output of this AI system? And I'll give you another tiny example. This is a project that we did on skin tone at Google. We launched it about 2 years ago. And the problem that our researchers had, this was a project led by Dr. Heldreth, Dr. Monk, and Dr. Olanubi, was that AI models behaved erratically when taking photos of people with darker skin, right? The hypothesis that we had, thinking back to that original model, is that both humans and AI systems are making probabilistic judgments based on an unclear understanding of what the human was doing. And the solution developed better metrics for both of them. We created such a scale, we launched it, and we've been doing a lot of testing globally about it. Okay, so my punchline again, the history of AI is really just an accelerated version of the history of the social sciences. And because of our role as UX researchers, we have a lot more power than we think we do. So rather than shy away from working with our computer science partners, it's time to embrace them, to talk to them about where their models come from, what they're trained on, and what the output is that we want them to have. Thank you.